Thank you very much. Thank you for inviting me. It is really an honor and a pleasure to work with Magaldi. I'm working with Magaldi for maybe 5 years or 6 years, maybe now, to this amazing system. And I would like to give you my presentation about why I consider MGTES the most effective electric thermal energy storage in the world now. But I cannot, because I've been asked to give you some figures about energy storage in power systems, so I will obey and I will just give you some figures about that. And yeah, I think we all know about the importance of energy storage in power systems, as Maria Carmen was explaining. The global electricity demand is about 20,000 terawatt-hour every year, and the energy storage global installed capacity is in the range of 10,000 gigawatt-hour, which is, in terms of power, around 360 gigawatts. So it means that the energy storage capacity in the world is 0.03% of the global electricity demand. This is the situation, the starting point of our discussion now. In terms of power, 55% of this capacity is pumped hydro, and 44% is batteries. Like battery energy storage system are growing exponentially, and on the next year, in terms of power, the capacity of electrochemical energy storage system will be higher than pumped hydro, which is new. But in terms of energy, this is not true. In terms of energy, still pumped hydro has more than 95% of the global energy storage capacity. So batteries are growing, yes, but in terms of power. So the services related to the battery energy storage systems now are more power services than energy services. If we give a look to this theoretical curve, it is the result of modeling simulation for the European power system. We have the storage fraction needed in a power system versus the variable renewable energies, wind and power, essentially. So we see that now we are in a situation in which the variable renewable penetration is in a range of 12%. Globally. So the storage fraction is, as we saw, 0.02, 0.03%. But when the penetration of renewable energy, wind and solar, grow, and as you see, the curve shows completely different figures. With roughly with 80% of wind and solar penetration, the need for energy storage is about 1% of the annual global demand. So, for example, if the demand is 28,000 terawatt-hour as it is today, this means 280 terawatt-hour of storage capacity, which is 1,000% more than the actual figures today. Okay, so what we should expect for the future? First, the battery energy storage system capacity in terms of energy is growing, and it is expected that in the next years, in terms of hours, in terms of ratio between energy and power, it can grow up to 10 hours. But still, the pumped hydro technology is in the range of 20, 30, 40, 50. Nowadays, the average is 50 hours. So still, there are these two areas of services, power and energy, covered by these two technologies. And in the middle, there is a space of optimization. And also, as we saw this morning, there's also a space, a big space for heat decarbonization through electrification, which adds another dimension to this problem, and open a space for the electric thermal energy storage technologies. Maybe we can go to the next slide. Yeah. In the midterm, 2030, it is expected by the International Energy Agency a new capacity of 5,500 gigawatts of variable renewable energy in general, but most of this capacity is variable renewable energy. So it means that we are going to expect around 30% of wind and solar penetration globally in the power system. And so this will lead to the needs of 10 times the energy storage capacity we have today. 10 times in a few years. And this capacity cannot be covered only by battery energy storage services systems, because of what I was saying, we need also long duration energy storage in the power systems. So if we go to the next slide, yeah. What does it mean for our country, for example, for Italy? There's a very recent study, modeling study of Polytechnic of Turin, showing the expectations of the energy storage capacity needs in the Italian power system. We start from today. Today in Italy we have about 30% of wind and solar penetration in the system, and I mean in 2030. I say today 2030 because of course, yeah, of the time scale. And the capacity is roughly the existing one, because Italy has a large pumped hydro energy storage system. So less than 100 gigawatt hour capacity. But in 2050, also for our country, with the wind and solar penetration, which will go over 75%, the energy storage capacity will have to reach not less than 250, 300 gigawatt hour. And it is expected that half of it should come from pumped hydro. But is it possible? Is that possible? Is it possible to develop 20 gigawatt of new pumped hydro systems in Italy? What if it is not? So there is a huge space, according to us, for alternative technologies, not only batteries, not only pumped hydro, but also a cross-sectoral energy storage system like the electrical thermal energy storage system, which can provide services for balancing the system, but also ancillary services, as Maria Carmen was saying. And furthermore, there is this last point of trying to electrify the industrial heat. And while doing that, also giving the power system services in terms of energy storage. So integrated machines like this one in front of me are crucial for this, because they can answer the question of having on power system side the balancing and ancillary services, and on the industrial side the decarbonization of heat services, at least for temperature that ranges between 200 and 500 Celsius degrees. So yes, I think I can stop here also, because I think it's lunchtime. Or yeah.